Okay, welcome everyone. Today is Thursday, May 20th. Okay. All right. So it's just to spend, okay, let me just to turn off the desktop sharing so that people online can actually see a big video of this in-class kind of activities right now. I hope you're seeing in-class video, right? Webcam is on now, so. Okay, so hopefully you watch what's going on here in class. So today is actually the first day in class, so I'm going to do a little bit of activity. Okay, it's not so bad. I want you to create one of those things. This is actually going to be, well, actually only two people in masks, so it's kind of easy to recognize your face nowadays. But so you're all Korean, right? Everybody's all Korean without having mask. That means, okay, good. So I have to wear a mask no matter what, but anyways. So I want you to create one of those things. This is, I want you to create one of those things. Can you see it? Okay. Everybody's all Korean without having mask. That means, okay, good. So I have to wear a mask no matter what, but anyways. So I want you to create one of those things. This is, I want you to create one of those things. Can you see it? Okay. All right. Yeah, so when you come back on Monday in class, okay, you're going to do the same thing. So you're going to create one sheet of paper, protected film. So you are going to write big, better your name. And then if you want to add the small, tiny, like a mascot, this is, by the way, avatar. Ernie, the engineering bird, as we saw. Okay? That's my avatar or mascot. You can create your own if you want to. If you don't like that kind of stuff, that's fine. So I'm going to give you a sheet of paper with a protective film. Okay? Take one. Take one. Take one. Here we go. And then please take the paper out of the protective film. And I give you a marker. Don't worry about it. I have a bunch of markers. You can choose either red or blue, either way. Okay. Yes. You will big marker. Red. Okay, so please use this marker, write your name really big. And then if you are reading, you can put your own avatar or mascot or whatever best to describe who you are. If I want to remember your name, oh, this is the person with a bird on it.
Do you carry a landscape or portrait?
Either way, it's fine.
Okay.
I don't mind. So it just like that. This is me, okay? So everybody in classroom is doing this right now. You're going to do the same on Monday, don't worry about it. Okay. And then after you're done, just to put the paper back into the plastic film, protective film. Okay? Good. Do you want to close the door or keep it open? Either way is fine, but.
I like it.
You okay with it? All right. Yeah, it's admissions trying to attract more students. Yeah, right. I'm always the favorite pick of admissions. You know, I receive phone call like twice a day, all the time. Oh, I'm looking. Oh, the parents wants to talk with you. That means, oh, do you want me to encourage them or discourage them? Which one is it? Actually, you're going to keep this sheet of paper, so if you want to continue working on it, you can do it later, that's fine. I don't want you to spend an entire class just making up your own thing. So you can continue working on it after the class is over. So let's just make it ready, okay? So what I'm going to do now is, I want you to hold up a sheet of paper just like this. You know what I'm talking about? Okay, I want you to do this. Then what I'm going to do, I'm going to take one sweep of video. This is a record of your attendance in class. That means, okay, who are you and where were you sitting on this particular day? It's okay, you can continue working later, okay, Patrick? That's fine. Okay, I take one sweep of video and that's it. This is attendance for today. I hate doing this, but school wants me to do. If somebody gets sick, who was sitting next to it kind of thing. So that's the tracking purpose only. Have nothing to do with your grade or anything. Don't worry about it. It's just a requirement, a stupid requirement I have to do. Okay? And then you just keep that sheet of paper with protective film. Bring it with you all the time. If you show up in class, you need to have that. Okay? So please keep it. Or that's good. You can file up with your file folder. That's great. Good idea. So please bring that protective film sheet of paper every class. Okay? So I'm going to take attendance. Do you have any question, people online? Looking good, please react. React means choose something, okay. We don't have any negative reaction. Okay, good. So you're going to do the same thing on Monday. All right, so let's get started. So let's just take a look at updates. So this is the update I announced twice yesterday. One of them is basically handout Greek alphabet. Okay? This is both lowercase, uppercase, Greek letter. Oftentimes in engineering class, we are going to use Greek character to represent certain things. Okay? So you need to be very familiar with Greek characters. Okay? By the way, those are pronunciation in Japanese language. Don't worry about it. So I really kind of writing them. Well, you know those things: alpha, beta, gamma, blah blah blah. But those are kind of tough. This is psi, omicron, pi, rho, sigma, tau, epsilon, phi, chi, psi, omega. I can't pronounce those things, so I'm writing Japanese language here. Don't worry about it. Okay? So this is Greek character. We use that quite often. Okay? Both uppercase, lowercase. All right. And the other announcement is, of course, today, all of a sudden, today's in-class lecture. I'm all cleared. I was negative. And then if you choose to stay online, that's okay. So those 3 people decided to stay online, that's all right. However, if you cannot come to class on the day of, let's say, quiz, okay, the quiz will happen whenever you turn in your homework assignment. So I'm going to announce it, okay? Let's say hypothetically, okay, homework of section 1A, 6 programs will be due hypothetically Tuesday next week, okay? If so, that means you have to show up on Tuesday. No, Tuesday's all remote online. Sorry, it can't happen. So that means I have to make it Wednesday. So hypothetically, if the homework of section 1A is due Wednesday. We never know, but if so, you have to show up in class on Wednesday to take the quiz at least last 10, 15 minutes. At least, okay? At least. Otherwise, you're going to miss the quiz. And if you have no excuse for that, you get 0 score. Okay? Let's be careful. But if there's no quiz on that particular in-class lecture day, you can do in online attendance just like there's no problem. It's about same thing, isn't it? You're just physically be here, or you're just physically sitting in behind your computer. It's probably the same thing. You can still ask questions. You can take notes. You can participate discussions if you want to. Okay. All right. Do you have any question about the lecture? Like I said, every Tuesday will be still everybody online lecture. Okay. The reason, I don't know, because it's easier for me to do all online. This one is more difficult. I have to set up everything. I have to deal with physical people and online people at the same time. Yeah, a lot more work than just to do everybody online. That's so easy. So I probably need to take one class a week a break. Every Tuesday is online. Okay, that's why. There's not much strong reason. Anyways, okay. So again, since you are online, but I will encourage you speaking up anytime. If you have questions, just to start speaking. You can raise your hand if you're nice, but sometimes I may miss it. Okay, so this is in class. And then if you have a question to someone you know in class, you can ask question if you want to. You can communicate. Okay. Anyways, so let's get started today. So I think we stopped at page 5, class. Okay. So let's just pick up where we left off in page 5. We're going to start talking about vectors and scalars. So let's begin with a question here. Question. What is a scalar? Yeah, go ahead. You don't have to raise your hand. You can just start speaking.
Scalar is just a value. It's just a number.
Actually,
it's like it's like the distance. It's just the distance about the direction.
You're talking about quantity. So if you start saying just a number, that actually gives you a sort of different impression, because just a number is a number. It actually does not have any units with it. Something like, have you ever heard of Reynolds number? What is Reynolds number? Oh, it's a number. Well, what's the unit? Well, there's no unit. It's just a number. That's Reynolds number. Now, quantity, literally, something that actually comes with some kind of unit, quantifiable, measurable thing, such as you said distance. That's great. Distance, but the distance may be a vector. I don't know, because distance in this direction. If so, that's a vector. Here we go. Position vector is a vector. But the magnitude only is a distance. If so, that's a scalar. Okay, here we go. So let's just say a quantity which is measured or characterized only by, this is a quite important thing, magnitude, not the direction.
Professor?
Yeah, go ahead.
Could you put your screen back to the desktop?
Sorry. Good point.
Thank you.
I forgot to share my desktop. Here we go. How's that?
Much better. Thank you, sir.
Sorry about that. Sometimes that happens, so please don't hesitate to speak up. Okay, so this is a quantity characterized only by magnitude. So example, of course, a good example is such as mass. Oh, that has a kilogram or slag or whatever. We talked about that, right? What is the standard unit of mass of the United States? Slug. And then if you walk out of this classroom and you start using slugs casually, people look at you and say, what are you? Oh, I'm engineer. Oh, that's why. Okay. We never use slugs. Slugs is this thing. You know, that the slimy weird thing, that's a slug. No, it's a slug is a unit of mass. It's a standard in engineering. Yeah, here we go. Well, we use pounds for mass, fine, but I have to always convert it back to slugs. Okay, that's you, because you're engineer. Okay. How about volume? Yeah. Somebody said distance or length could be. This is only a magnitude. So this keeps going. Okay. So those are typical scalar properties. We oftentimes use that to quantify something. Now, what is the vector? Go ahead. You don't have to raise your hand. Just speak up.
It's a quantity that's characterized by magnitude and direction.
Ah, both two things needed. That's right. A quantity. Misspell. Characterized by number one, magnitude, and number two, direction. What is a good example?
Force.
Force. Oh, good one. Of course, force. So force is a vector, mass is scalar. Interesting. So people oftentimes use, okay, pounds of apple. If it means pounds mass, it's a scalar. Pounds force, it's a vector. So you can say, oh, are you talking about 5 pounds mass of apple, 5 pounds force of apple? Which one is it? One is a scalar, one is a vector. What are you talking about? You can, please don't do that. This is just a joke. If you do such a thing in Walmart, you know, they call police. What else?
Velocity.
Velocity. Interesting. This is actually very, very important. Velocity is a vector. However, okay, if you're talking about speed, speed is a scalar, isn't it? So let's be careful. You casually use the speed and velocity interchangeably. You cannot do that actually. Speed is a scalar. Magnitude of velocity is a speed. Okay? Velocity, if you're talking about, you need to show the direction also, as well as magnitude. Okay, and there may be position. Position requires both direction and then length or distance from another location, okay? So again, position is a vector. However, you are talking about distance. Distance is actually a scalar. Here we go. So you shouldn't use those two things interchangeably. Those are different. One is scalar, one is vector. So in this class, we are going to kind of spend some time dealing with vector to begin with. It's quite important, okay? So whenever you describe a vector, vector is different from scalar. This is actually very fundamental, but still, you know, upper division students oftentimes do this confusion. You know, if you write an equation based on scalar, you must stick with the scalar notation. If the equation is given as a vector equation, you have to use the vector throughout. You need to be consistent. You know, sometimes students taking my upper division class, such as aerodynamics, you know, they express Euler's equation in vector form. I basically say it's big X mark and put 2 out of 10. What are you thinking? Did you take statics? Kind of. So please avoid those kind of things. So if you handwrite vector, let's say quantity A being a vector, you're going to put overhead arrow. This indicates this A is now a vector of A. This, okay? This is a handwriting standard, so oftentimes used in everywhere. By the way, this is 201, sorry, typo. 201, not the 207. Sorry about that. So this is the ES201 statics class. So this is handwriting standard. I'm actually going to use this throughout, even your notes. This is standard in this class. However, if you look at some textbooks, okay, some of the textbooks actually indicate this as a vector. So this is a boldface type font. They change the type of the font and they're indicating, hey, since this is a boldface type, this is a vector. It's kind of confusing, but you have to follow through that notation sometimes. Some textbooks actually do this. Now, in my note, I don't do this. I consistently use this as a vector as well as the handwriting standard. Now, if you astrotrack, this is a weird expression, but some of the astro people, spacecraft, astronautical engineering people use the underline to represent being a vector. So you need to get used to it. Some of the professors in astrotrack, they actually use this notation. Okay, so let's be careful. Everything is the same meaning. It's a vector, okay? Now, vector also comes with magnitude. Magnitude is basically take an absolute value of a vector. So you're going to either notation of that. So this is the magnitude of this vector value, or just simply magnitude is a scalar. So whatever the value within the vector is a scalar A. So scalar A is a magnitude of vector A. Okay, either way is fine. So when you represent a vector, you have to have both magnitude and direction. Magnitude is usually how long this arrow marker is. So this is a scale of 1. Suppose this is a 4 kilonewton of force, okay? So this is, each one of them is 1 kilonewton force. So you have to draw a kind of long line to indicate 4 kilonewton of force. So this length of the arrowhead is going to be a magnitude usually, okay? So a bigger force comes with larger or longer length. And then direction is usually angle measured from somewhere, some kind of a reference point. So in this case, this is probably x-axis, horizontal axis x, if this is a Cartesian 2D, okay, coordinate space. We never know, so I'm going to erase it. Usually x, but we never know. Some kind of reference line, you draw it in space, then you're going to measure the angle from there. That's going to be a direction of a vector, okay? And then direction of the vector, of course, comes into play. So you're going to put the arrowhead, indicating this is the direction of the vector, okay? So those are just standard. Next page. So we are going to take a look at the very fundamental vector operations. Vector operation is a vector addition, subtraction, multiplication, division, stuff like that. But here's the bottom line. You can add the vector, but you can never subtract vectors. Did you know that? So please don't try to subtract the vector from something else. You can never do such a thing. Bottom line. Okay? So let's just take a look. The multiplication and division to begin with. So if you want to multiply a vector A with a scalar lowercase a, you can do those things easily. Just multiply AA and take a magnitude. Magnitude, wait a minute. Yeah, magnitude is A times A. So you're going to take up the magnitude of vector A, the value of that magnitude multiplied by scalar A you're multiplying with. That is going to be a magnitude. And the direction is the same. It never changed the direction. Now, you can never divide vector by a scalar. You can never do that. Did you know that? You are going to take an inverse of a scalar, then multiply it. That's the division. So let's be careful. So pure mathematical sense, there's no such a thing of, okay, well, here's a given vector divided by scalar. You can never do such a thing. Scalar is inversed first and multiply it. Okay? Once you start using MATLAB, you're going to realize those things, I hope. Did you take that class, by the way? Huh. So do you think MATLAB can divide? No. MATLAB does operation inverse first and then multiply that inverse, always. Okay, mathematically speaking, you can never do such a thing. Okay, so this is some examples. So this is the original vector A. If you multiply with the scalar 2, this is a 2A, direction is the same. Now, if you multiply with minus 1.5, of course, magnitude is 1.5 times larger, but the direction is opposing. So negative sign means direction is completely flip-flop. So this is a 0.5A. That means flip-flop 2, and then, okay. No, this is Still multiplication, that's right, 0.58. So this is basically divide by 2, isn't it? Yeah, that's right. So if you want to divide by 2, let's just basically inverse it, flip-flop it, make it 1/2, and multiply 1/2. That's going to be 0.58. Okay. Here we go. So the negative of a vector can be formed by multiplying the vector by the scalar -1. So it is going to completely flip-flop the direction. Here we go. And then vector can be added. Only be added. You can never subtract it. So let's be careful. So if you try to subtract the vector a minus b, let's say this is a vector a, this is vector b. I want to do a manipulation of a minus b. That means you are going to first of all multiply by -1 of b, flip-flop the direction, then you're going to add. That's the only thing you can do. Okay, you can never subtract it. So if you add a plus b, okay, so this is vector a. This is vector b. So you are going to kind of moving those things together and connect it up here in the root, and then place this vector b in here. This is called the parallelogram row, creating a triangle. And then figuring out this length of a triangle. That's the vector addition of a and b. This is called parallelogram row. This is the only thing you can do. Please don't do anything else. So subtraction means you are going to add flip-flopped vector b with a, right? It's the same thing. So next page. So, oh yeah, this is a subtraction. Here we go. So this is vector a, so this is vector b. I want to do a minus b. That means you're going to find out minus b first, then make it together in cross contact, and then move this vector to here, creating triangle, then find out the length of this triangle. This is a vector subtraction a minus b. Okay. Parallelogram row. Here we go. Also, another thing, suppose if a single vector is given in a space, okay, any space. This is a two-dimensional space. I want to have components of this vector in certain directions. Let's say you're going to define a direction A. You're going to define direction B. May not necessarily be 90 degrees right angle. It could be any two directions. And in this direction, how much component of this vector is still acting on it? This much value. In this direction, this much value. Those are called components of this vector R. Let's say call this RA. Let's say this is called RB. So vector R still can be constructed by adding up RA and RB, right? This is a component. So let me just. So this is these are components. Component of vector R in axis A. This is a component of vector R in axis B. If you add them up, you can still construct vector R. Okay? So this vector R is oftentimes called resultant. Resultant of those two components. You can resolve a vector into any components. In other words, lots of components actually being resolved into single vector. Okay, so this is quite a bit. This actually can be done a lot of times in many classes you're going to take from now. Very, very important concept of vector quantity. Vector quantity can be resolved into a resultant vector, or you can you can actually resolve means divide into lots of different components. That's resolve. Okay, and then you can add them up to come up with a resultant. The resultant can be resolved into many components of vectors. Make sense? If you try to drag a huge rock, you can rely on one big machine to draw, or you can pick up thousands of people putting lots of ropes around the rock and each person pull in certain direction. Resultant is one big machine pulling the rock. It's the same thing. All right? So something like that. All right. Next page, page 8. So let's just talk about for a moment what is the typical application of a vector analysis. It's a force. Force is a vector. So we are going to basically pick up as a first application of using vector calculus using force. Force is actual thing. Okay. So let's just try to solve some real engineering problem. Usually involves with force. Force is a vector. That's a good thing. So let's begin with a question. Okay, once again. Question. What are two common problems? Type of problem. Let's just say types of problems. Here we go. In engineering mechanics, you probably don't have any clue. There are probably two different kinds of problems you're going to deal with. So most likely your first homework assignments, first quiz will be this kind of problem.
Moving something up a slope of some weight.
That is actually a little bit further. It's a little too advanced. Very, very fast type of problem is two things. One is, okay, suppose if I give you force and force, maybe two forces, maybe three forces, I don't know. You have those two forces. What is the resultant? Let's find out. That's type of A, okay? So this is a find a resultant type of problem. Find a resultant of forces. Could be two forces, three forces, 4, 5, I don't know, resultant of multiple forces. Second type of problem, it's opposite. Suppose if I give you this force resolve into two directions given, or three directions. Can we do such a thing? I don't know, two directions. Resolve a given force, let's say, into something called components. Okay? So those are the two different types of problems you're going to encounter probably in section 1A. Okay? So let's just take a look at example here. First of all, the resultant force and component forces. Okay, so suppose if you're given forces F1, F2, and F3, and then let's say the homework assignment says, okay, find out the resultant of those three forces. How can we do that? You're going to add F1 plus F2, come up with this force. This force is a result of F1 plus F2. This force can be added together with F3. That is going to be F1 plus F2 plus F3. That is going to be the final resultant force you're going to get. Okay? So this is the resultant of three forces. This is F1 plus F2 plus F3. How would you do that? Of course, you're going to use the geometry. Okay? Oh, as you notice, this is a bold typeface font. Okay. The magnitude of the resultant force can be determined graphically from the cosine law. Oh, this is quite important. The magnitude of two force components can be determined graphically from the sine law. What does that really mean? So this could be a key for this section 1A homework assignment. Do you remember the Ernie the bird tried to solve the very first homework problem and screwed up completely? Why is that? He didn't use the whatever, the sine or cosine, whatever the rho that's covered here. So let's just to stay focused. So this is the law of cosines and sines. So I'm going to pick up a triangle right here, okay? Let's see. So I'm going to pick up this triangle for a moment, okay? And I'm going to sketch it down here. So that is the triangle I picked up from this figure. Once again, it's very difficult to draw a straight line. I always struggle with this device. It's easier to do that in piece of paper with a straight edge. Okay? No, you can't do that. Okay. So this is a triangle I just picked up from here. Okay? So I'm going to define the distance of this edge. The length of this edge is A. This is edge A. This edge, the length is C. This edge, the length, sorry, forget about that. Sorry, I was looking at something. Let's say this is A, sorry. This is B, and this is C. Okay, so far. So this triangle is made up by three edges. Length here is A, length here is B, length here is C. Now also, this triangle comes with angles, three angles. Now let's say the angle here opposed against edge C, we're going to call this lowercase c. So this is angle C opposed against edge C. So this is the angle lowercase b opposed against edge B. This is the angle lowercase a opposed against edge A. So now you see three edges, A, B, C, and three angles correspondingly, A and B and C, lowercase. See that? Okay. So first of all, let's define cosine law. Cosine law basically says that the length of the edge C can be given by taking a square root of length of edge A square plus length of edge B square minus 2 times multiplication of edge A and edge B multiplied by taking the cosine of angle C. This is cosine law. Quite important. So in other words, suppose if you see a triangle and then this length C is your unknown, but you know the lengths of edge A and B and also the angle in between angle C. If you have that much information, you can determine the length C. That is actually being used to determine this resultant, of course. Okay, think about that. And as you add F1 and F2, you're going to create this triangle. So F2 is going to be moved here as a parallelogram row. Okay, so you know this length. You know this length. You know this length. You know this length. Let's suppose if you know this angle, you can determine the length of that. That's the magnitude of resultant, F1 plus F2, right? So using cosine law, you can determine the magnitude of resultant, okay? Graphically speaking. All right. So what about sine law? This is something that Ernie the bird didn't apply, and then Ernie the bird gets 3 out of 10 for the first homework. That was the tragedy. You have to avoid it. So what is the sine law? Sine law basically says the length of edge A divided by sine of the angle of A, which is opposing against edge A, must be equal to length of edge B divided by sine of angle B, which is the angle opposing against edge B, which is equal to length of C over sine of angle C, which is opposing against it. This is called sine law. Okay. So this is important concept needed to solve the homework, very fast homework, the Ernie Bud screwed up homework. Okay. Any question? So this is probably the most important item for section 1A. All right. So next page is, of course, class example 141. I think I already showed you on the first day. Okay. So what should I do? Oh. So let's just take a look at yeah. Once again, let's just take a look at what Ernie the bird did. Okay, so this is what he did. Okay. So the one important lesson here is, the Ernie the bird, actually controlled by Dr. H, trying to kind of demonstrate the solution of this first homework assignment using the digital device. Man, this is painful. First of all, sketching this thing to begin with is very difficult to do using digital device. It's very painful. It's like much easier to use it by, just use your paper. That's easier. Okay. And then anyways, I tried to kind of figure it out, everything, and blah, 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 did the totally wrong thing. Okay? The solution for that, let's just take a look at the graded work of this Ernie once again. So this is a graded work. If I grade this kind of work, first of all, hey, you completely forgot about the sine law. Here we go. So you are going to resolve your force here into two directions, x and y prime. This is the x coordinate, this is y prime coordinate. You resolve it first, so graphically resolve it. Okay, and then find out this magnitude and that magnitude. So basically, sine law says this magnitude divided by the sine of the opposing angle. Where is it? Which angle? This angle? Opposing against is which angle? This angle? Something like that. This magnitude opposing against this angle is equal to this distance divided by this angle. Something like that. You have to apply sine law. Okay. And of course, if you take a look at the course homepage, this first homework assignment solution is already given to you. So this is a bonus, okay? So you know the solution already. So this is a solution I did by myself. Okay. So this is very, very important. You probably please listen to me. If you don't listen to me, that's okay. It's your freedom of your choice in this country. This is a free country. If you don't want to listen, just don't listen. That's fine. But here's the point. How can we make this class super successful so that you're going to kind of trickle down to solid mechanics, dynamics, thermodynamics, fluid mechanics, whatever the mechanics class is, you go for really good. Here's the bottom line. Be organized. Number 2, spend more time going very slowly, accurately. That is actually much faster than go sloppy and do it all over again. Do it all over again, make a mistake, let's fix it. Sloppy work is going to take more time. People think opposite way. People just think, hey, I'm a sloppy person, Please don't be an engineer. Please fix yourself. So I realized, as I try to solve this problem, I'm going to pick up a piece of paper, pick up a straight edge, spending some time, not so much, doing very accurate sketch. Very accurate sketch. If I say 60, I try to make it 60. If I say 10, I try to make it 10. Very accurate sketch to begin with. And if you do it one shot, that's it, that's done. If you do a sloppy job, you just, oh my goodness. Oh my goodness. It's gonna take more time. Guaranteed. Okay, so slow down yourself, do a very good accurate sketch to begin with, do a geometry first. Next, you're going to draw a very accurate sketch of figures. So this is the x coordinate, this is y prime coordinate, this is the force given 200 newtons. You are going to resolve into two directions, actually resolve into two directions, fx and fy prime. So those two are the forces you want to have. I'm going to apply sine rho. In order to find sine rho, you need to have all the information of angles opposing against your edge, right? Accurate sketch can only give you that kind of information. Don't do a sloppy job. Always use the straight edge. Let's do it on the paper, not the digital device. Digital device is terrible for this kind of thing. Okay, any question here? So this is the very first homework assignment. Solution is already given to you. So let's just get started right. So this is my suggestion. You already have your note downloaded, I assume. Okay, so this is your note. You download it and then you print it out. You brought it with you in the class. You're taking notes on this notes. You're taking your own memos and then complete this note, right? I hope so. If you're not doing it, it's your decision. I don't care. So now, if you hit the class example 141, I'm going to do it now. Once I complete this class example in class, this homework assignment is now automatically assigned to you. You just go ahead and do it immediately after this class. Okay? But this is your own solution. You just keep it for yourself. Don't turn in as it is. When I announce homework due date, this is what you need to be doing. You go back to your home page, download this worksheet. Okay, this is a worksheet PDF. You can download in either digital device or print it out again. This is the second time printing, of course. Then take a look at your own solution in your own note. Try to remember what you did. Now this time, you try to explain what you did to someone else. That's me. You need to convince me if you want to get some credit. If I'm not convinced, even though you are doing the right thing, I'm not going to give you partial credit. Okay, welcome to engineering world. That's what it goes. It doesn't matter if you do the right thing or wrong thing. If you fail to convince others, you're not going to get any credit. That's engineering. So this is the very first step toward engineering major. So effectively, you are actually thinking that, hey, am I going to visit this same problem twice? Yes, of course. That's what you do. Every good A student in engineering do the same thing. Once you try to solve it by yourself, you're convincing yourself, okay, I understood this problem, I solved it. But that's your solution. That means you are the only one who can understand it. You don't have to organize, you don't have to explain, you don't have to show all the details, computation, whatever, what not to. It's your own solution. Great, congratulations, but who cares? You have to explain that to someone else. That is your homework submission. Okay, please do that. Oh, is that too tedious? Of course, engineering is tedious. It's better than making stupid mistakes and people die. All right? Okay, so let's just take a look at, where am I? Note. Let's just take a look at the class example 141. Okay? Again, it's very painful to do that in digital device, but I'll do. Let's take a look. Determine the magnitude of the resultant force and its direction. Measure the clockwise from the positive x-axis. So I'm going to begin with a sketch. So this is a sketch. So this is, looks like a hook or something. So you're putting the rope on the hook. So for a moment, I'm going to completely ignore the existence of the rope. So replacing the rope with a force, okay? I'm going to put the force 4 kilonewton in this direction, okay? 4 kilonewton. And then looks like 10 kilonewton force in 30 degrees from vertical direction. Very difficult to draw a straight line. So this is 10 kilonewton. All right. And then, of course, you are going to be given a coordinate, which is, this is a coordinate direction x. And this is coordinate direction y. And then, of course, this is also negative y direction. Okay. And then one thing which is given here is a 30 degrees angle. So this is a 30 degrees angle. So now I want to basically add them up by using parallelogram rule. So you're going to draw a parallel line, and you're going to find out the resultant of those two forces, just like this. So this is resultant force Fr. Okay? So there are certain things we know, certain things we don't know. Okay. So I want the magnitude, and also I want the direction. Direction is measured clockwise from the positive x-axis. That means this is, let's call this theta. This is what I know. I want to know. What is the theta? This is the direction. What is the magnitude of Fr? Those are the two things I want to know. Okay? So what can we do? What can we do? So how can we determine, first of all, Fr? Anybody? Sine law or cosine law? Which one?
Cosine.
Cosine law. So let's use which triangle to determine cosine law? So let's just use this triangle, okay? So let's just use this triangle. Okay, and then the magnitude is this Fr. The magnitude here is 4 kilonewton. Magnitude here is 10 kilonewton, isn't that right? So this is a triangle I just picked up from here. And do we know the angle? Angle here is theta. That's something I want to know. Do we know any other angle? This is 30. This is, oh, I don't know this. What else do we know? Oh, by the way, if this is 30, should the
other one be 32?
Should the other one be 32 means which one? This?
There's a law, isn't there like an angle law that
Yeah.
says if one side is something, the other side should be?
That's right. So if you pick up this triangle, okay, let's say. So this is a triangle. And it says this is 30. Of course, this is 90, right? So what's this angle? 60. That's right. So you know this is 60. That means, hey, this is 62, right? Yeah, but that's not enough.
With that,
That means the other side is
one.
120. So that means this is 120. So this is 120. Oh, this is good enough to move on with the cosine though. Let's just do that. Okay. So magnitude of Fy using cosine though is the square root of 4 kilonewton square plus 10 kilonewton square. Everything is in kilonewton minus 2 times 4 times 10 times cosine of 120 degrees. Do you have a calculator? I'm not going to do any calculation in class. I'm too lazy. So please compute and finish up this problem. Please participate, everybody, because you have to do this anyways in exam, right? So let's just bring your calculator. Let's do computation.
That's okay. Okay.
What's the value? Anybody? I insist everybody should participate in this competition. Your calculator, you have to do this all the time in quiz and exam. Let's practice, okay? Let's practice means, under the heavy pressure, can you still compute right? That's exactly the exam, right? Okay, go ahead.
12.5.
Go ahead, yep.
12.5.
12.5, any confirmation?
That's what I got.
Okay. What's the unit?
Good.
Kilonewton. That's right. Here we go. So now we know this is 12.5 kilonewton. Knowing that, actually solve this one, right? So let's use sine law. Sine law basically says that the ratio, let's flip-flop the ratio. So in other words, sine theta over 10 kilonewton must be equal to sine of 120 degrees over 12.5. I actually flip-flopped the ratio. We can do the same thing. It's okay. The sine law says 10 over sine theta is equal to 12.5 over sine theta, but you can flip-flop. Sine theta over 10 is equal to, anyways, ratio is a ratio. So this actually indicates what is the theta. This is actually easier to compute. That's why, right? I flip-flopped. So sine 120 divided by 12.5 multiplied by 10 and take inverse sine. Go ahead and do that. So everybody get busy. Use your calculator. Use your calculator. Can you get the right result under the pressure? That's the exam. Do it now. Do it now. Do it now.
43.85.
43.85. Any confirmation?
Yeah, that's it.
40.85 degrees. Okay. Sounds good. Please confirm, okay? All right. Great. Sorry about that. So this is the triangle. This is the triangle. All right. Like I said, I really don't like to use digital device to solve the problem. So I would recommend highly use piece of paper, pen and pencil, straight edge. That's the best. Okay. Any question here for this problem?
Yeah, can you go over the degrees again? I'm all slowing up. How you got 120 again?
This is 60, so this is 60.
Yeah.
So that means this is 60.
Yeah.
That means this is 180 minus 60, 120.
Oh.
That's
okay.
the same here.
Thank you.
Yeah, okay. I appreciate that kind of question. Anybody else? All right, good. Let's move on. So this is the homework 141 already assigned to you. Actually, solution is given, so this is just practice of how you do it, okay? Here's another class example problem, example 142, let's just take a look at it, okay? So example 142, the vertical force F, we don't know the magnitude, or actually know the magnitude. The vertical force F acts downward at A on the two-membered frame. Determine the magnitudes of the two components of F directed along the axis of AB and AC. Set F equal to 500 newtons. This is actually a fairly advanced problem in statics and also solid mechanics. This is something called frame. So if you apply the force F here, each member of this structure is going to develop internal force. Some of them are tensile force. In other words, the member is going to have a tendency to be stretched up. The other member have a compressive force. That means member is going to be kind of compressed, kind of force. You can tell that, right? So this force is going to probably pull the member AB, but try to compress the member AC, isn't it? So you kind of know the direction. Let's just zoom in. So this force F is kind of moved to here. So this is actually force F. So this force, let's call this force developed in member AB, FAB. This is actually tensile force. This member AB is kind of stretched, right? So this force is FAC. This member AC is kind of compressed. Those two internal force developed, added together, you know, is going to be the force F. That's what's going on here. Okay. So first of all, you are going to actually start with the sketch of this situation. So you're going to draw a line of member AB. So this is the line corresponding to this member. And then you're going to draw a line of member AC. Well, you know this is 30. Okay? And then along this line, you have force FAB. Along this line, force FAC is going to be developed. So you're going to add together, determine the resultant. That is the force F. That is the force F. In which you know magnitude is 500 Newton. Actually, I shouldn't do that. Magnitude is 500 Newton. So if you take a look at magnitude, this is 500 Newton. Here we go. So this is a situation. So the question is, okay, so what is the magnitude of FAB and FAC? What is the best method to determine such a thing? Let me just redraw in a little bit bigger scale. This is 500 Newton. A little bit bigger scale. Okay. This is FAB. Yeah, this is FAC. Okay. Here we go. And then one thing I know, the angle here is 30 degrees. And also, one thing I know, this is 45. It doesn't look like 45, but 45. This is 45. So if you draw a horizontal line here, okay, you can say this is also 45. The rest of it here is a 30. Make sense? And then knowing so, this is 60, isn't it? Okay. So now you are going to take a look at this triangle. Okay. So the triangle you're going to draw here. This is 45. This is 75. This is 60. Yeah. And magnitude wise, this thing is 500 Newton. This is FAB. And this is FAC. All right. Cool. So what kind of thing can you apply now? Sine law, that's right. So let's apply sine law. So let's apply sine law. I'm going to apply now sine law as it is. FAB magnitude. Opposed angle is 60, so sine of 60 degrees must be equal to 500 Newton opposed against 75 degrees, sine of 75, which is equal to magnitude of FAC opposed against angle of 45, sine of 45. Okay. So this actually squeezes out two equations, right? Magnitude of FAB, what's that? 500 Newton times sine of 60, is that right? Okay. 500 Newton sine 60 out of space, sine 75, right? What's the value? FAC is 500 Newton multiplied by sine 45 divided by sine 75, right? What's the value? So everybody please participate. Just copying the number is not going to help you at all. You're going to suffer in quiz and exam if you do that. Please compute.
Professor,
Go ahead.
for magnitude of FAB, I got 448.29 newtons.
448.29 newtons.
That's what I got.
Okay, confirmation.
AC, I got 366.02 newtons.
0.2 newtons. Any confirmation? Good, good. We got confirmation. It looks okay. Please confirm by yourself. Again, don't be lazy in classroom. You're going to suffer that in actual quiz and exam. So please compute. All right, good job. So those are the two different kinds of problems as you saw. One is, of course, you're going to be given multiple forces and find out the resultant. The other one is the forces given that resolve into certain directions. Two different kind. Of course, you saw it. So again, homework 142 is now assigned. Please work on it today. Homework 143 is also assigned. Okay, so get busy. Don't shove it until the last minute. Okay, I can start after Dr. H announces homework due date. That's a bad idea. That's the best way to flunk this program. Flunk this class. Okay, if you want to flunk this class, that's guaranteed answer. You know, you're not gonna do anything until last minute. I've decided to do such a stupid thing. Okay, lots of students actually go that route. You know that, do you? Don't do that. That's not engineering way. So today, right after this class, work on those problems. If you get stuck and have very difficult time, you can of course ask questions to me. That's fine. Send me a text chat on Microsoft Teams. If I'm online, you get instant response. And if you want to talk to me, just call in. Okay? All right. So let's move on. Page 14. Section 1.5, addition of a system of a coplanar forces. Now the term coplanar comes into play. Coplanar. What's the coplanar? Anybody? I think we talked about it yesterday. Go ahead.
They lie on the same.
Lie on the same plane. So typically this is two-dimensional problem. Two-dimensional, typically x and y. If it's Cartesian coordinate x, y, and z, you're looking at xy plane, 2D. So every force is lying on the same plane. So this is two-dimensional, make your life much easier than taking care of three-dimensional forces. Of course, you have to deal with three-dimensional force system later, but you have to deal with it 2D first. So let's take a look at coplanar forces. Okay. So this is Cartesian coordinate. Cartesian is, of course, you know, x and y and z, 3D space, Cartesian. You're going to look at the xy plane, which is the 2D. Okay. So in 3D, if you want to express force in 3D space, force vector, I'm going to express force in x direction component fx. This is the magnitude. 3D. Okay. So in 3D, if you want to express force in 3D space, force vector, I'm going to express force in x direction component fx. This is the magnitude multiplied by I over hat, and then force in y direction multiplied by j over hat plus force in z direction and k over hat. What are those over hats? Do you guys know that?
Maybe just the direction.
No, it's not direction. This is actually a vector too.
Oh, right.
Those are called unit vector.
Do you know why they went with I, J, and K?
Somebody made up that in the past. You can be something else. Some other countries actually use different notation. So this has an origin of who actually started this notation. IJK is specific for Cartesian only. Okay, if you're looking at the different the coordinate systems, such as cylindrical coordinate or spherical coordinate system, do we cover such a thing here? Possibly later. But if you have if you are looking at a different coordinate system, unit vector notation will be slightly different. IJK is only for Cartesian, but unit vector. Unit vector is a vector, okay? Unit vector means magnitude is 1. That's called unit vector. Magnitude is 1. And then I is a vector in the x direction. Magnitude is 1. J is a unit vector in y direction. Magnitude is 1. K is a vector in z direction, magnitude is 1. Those are all called unit vectors. Okay? So suppose if you have a magnitude of force Fx multiplied by unit vector I, this is going to be a component of force F in x direction, right? If you do the same thing, Fy times J, this is going to be a component of this force vector in y direction, right? Same here. Fz times K is a magnitude, and well, this is a component of force F in z direction. Now, this is a 2D. We are only looking at x and y component. Okay? If it's 3D, you need to deal with Fz also. Okay? Ijk. Now, notation I over hat. This over hat usually indicates this is usually unit vector. So oftentimes people use like, okay, so later on you're going to know like a cylindrical coordinate system, ER, E theta, EZ, comes with hat, hat, hat. Those are the cylindrical coordinate system, R theta Z. Those are the unit vector in each direction. R direction, theta direction, Z direction, cylindrical coordinate system. Don't worry too much about it at this moment. You have to deal with it probably starting from fluid mechanics or something. Don't worry too much about it. By the way, R and theta on 2D on cylindrical coordinate is called polar coordinate. Have you ever seen it? Polar coordinate system, R and theta. Okay. So anyways, if it shows up in this class, I'll cover that. I'm not sure. Okay. So essentially, you are going to deal with very first thing of a coordinate space. So coordinate space is given as a Cartesian coordinate. This is how you express your vectors in Cartesian 2D space x and y. Okay. So suppose if the force is given in 2D space x and y plane, component of this force in x direction magnitude is Fx. Component of this force magnitude in y direction is Fy. Multiplied by each unit vector in each direction gives you the component vector of this F in each given direction. Does it make sense? So that you can express this force vector using each component vectors. Okay? Go ahead.
But why do you multiply it by 1, like the unit vector?
Unit vector need to give you a direction for a magnitude. Right? Multiply 1 retains this value, but you actually give a direction, right? So you are going to turn the scalar into vector by multiply by unit vector. Unit vector has a magnitude 1. That means multiply by 1 means the same magnitude anyway, but the direction is given.
Direction.
That's right. Direction is added. That's right. Okay. So anyways, the resultant of coplanar forces, resultant means, suppose if you're given F1, F2, F3, 3 force vectors in 2D space x, y. Let's say, hey, find out the resultant of all of those 3 forces. How can you do? Well, how can you do? Well, you can do it, of course, graphically. Let's just add F1 and F2, coming up with the resultant of F1 and F2. Then let's just add it with F3. Okay, here is the resultant. You can do that, but suppose if I give you like a 10 forces in XY plane, go ahead, do it. Graphically, that's a nightmare problem. If I want to flunk everybody in midterm, I'll do that. Okay, it's a nightmare problem, right? Graphically speaking, but you can do alternatively speaking. You represent each vector in Cartesian. In other words, F1 can be dissolved into two force vectors. This is something called F1x, right? F1 vectors x direction coordinate component. This is F1y. This is F1's y direction component vector. So each one of those forces can be resolved into x and y direction component just like this. F1 is going to be resolved into F1x, F1y. F2 is going to be resolved into F2x and F2y. One of them is minus, of course. This is F2x, which is a negative x direction. That's why it's minus. Right? F3 is F3x minus F3y, of course. This is negative y direction. That's why it's negative. So anyways, each one of those can be resolved into x and y components. And then each component can be added together. Some of them are negative because it's a negative direction, but you just sum them up. Okay, so you are going to resolve into x and y component for each. So all the x direction component, this thing, and this thing is added together. All the y direction component, this thing, added together. Then come up with resultants of each direction. Okay, so this is the resultant for each direction. So this is going to be now added together to come up with resultant force. Does it make sense? Okay, so this is one way of doing that. So this is the magnitude of resultant force is going to be resultant is in x component square plus resultant in y direction square. Add it together, take a square root is going to be the magnitude of FR, and then angle theta is taking an inverse tangent of magnitude of FRY divided by FRX. So now you can sort of easily, mathematically I should say, not easily, you can basically mathematically rather than graphically determine the resultant force, magnitude, and direction. Okay, so this is called x and y Cartesian 2D coplanar vector manipulation. So this is the class example. Let's just to try doing it. Okay. So in each case, resolve the force into x and y components. Report the results using Cartesian vector notation. Looks like 4 problems. Okay. Okay. So let's begin with A. Okay. A is so it looks like this is y, this is x, and force F 10 pounds is in this kind of direction. So this is F, this is a 10 pounds. Is this a pound mass or pound force? Force, of course. This is a force, that's why there's no subscript. If this is a pound mass, subscript M is required, be careful. Anyways, and then you know this is a 60 degrees. So what you need to be doing is we are going to resolve into x and y. This and that. And then you're going to have this looks like fx. So fx, the magnitude-wise, fx is, what's the fx? Anybody?
It's 8.66.
How did you get that?
Oh, well, I did the
10 pounds?
What did I do?
What did I do?
I knew that since that's a 90-degree angle on the bottom left.
Right, right.
I moved I said the other one was 33 degrees.
That's right.
And then
Or this is 60, either way.
No, I mean like the.
Or this is 30.
No, the other.
This is 30.
Yeah. I was using that triangle.
That's right. And
And
that means this is also 30.
I said that the cosine of
Yeah.
that angle times the hypotenuse length.
That's right. So this is 10. So this is 10 times cosine of what? 30. Or 10 times sine of 60. Either way is fine, right? It's the same thing. So what's the value?
was like 8.6.
8.66, that's how you get that. So 8.66 pound. Okay. Now, the other way around is Fy, which is, just to slightly change the color here. So this thing is, oops, 5 more minutes. So this thing is Fy magnitude. This is minus, because it's a negative y direction, 10 pounds cosine of 60, or minus 10 sine of 30, in which
It's negative, or, well, 5 and then.
negative 5 pounds. That's right. So conclusion here. Okay. So what is the force F resultant? This can be resolved into 8.66 I minus 5J pounds. Okay. So this is the conclusion of A. Now, the rest of the problem is about the same. So please do it by yourself. So B, C, and D. Very similar. You're going to resolve into X and Y component. Okay. Practice by yourself. I'm going to give you this page today, okay? But please practice by yourself. I'm going to show you the rest of the solution, B, C, D. I'll send you updates today. Let's stop here today. So that means, hey, technically speaking, I'm done for this class example 151. So please do your homework 151, 152. Wait a minute. I have to do another class example 152 next class. So too bad. Homework 152, 153. You can sort of do it, but officially not assigned yet. Okay? Any question? So next class, actually next week, Monday, we're going to pick up page 18. Let's do one more class example 152, and let's get it done. We're going to move on to section 1B. Any question, people online? Question? Marker. Thank you very much. Just leave your marker on your desktop. I'll pick it up later. Thank you very much. So have a good day. We're going to see you back on Monday. Have a wonderful weekend.
Nice weekend.
Yep. See you on Monday.